Hello students, welcome to Lucky Learning. In this video, I'm going to discuss address sequencing in control memory. Very first, we should understand what is control memory. The control memory holds a fixed microprogram and which cannot be altered by the occasional user. Only the person who knows the computer architecture can program the control memory for issuing the micro operations. The micro program consists of micro instructions and that specifies various internal control signals for the execution of register micro operations. And you know that each mission instructions initiate series of micro instructions, means one computer instruction will have many micro instructions and each micro instruction can have micro operations. And these micro instructions to be stored into the control memory for fetch the instruction from the memory, for evaluating the effective address and executing the respective operations and returning the control back to the next instruction. We have to use control memory. As we know that user program is divided into mission instructions and each mission instructions, let us say add is one mission instruction, will have a micro program for that mission instruction. And each microprogram is a collection of micro instructions. Means it is not going to be performed in a single operation. It is going to be divided into multiple operations. So we call micro instructions. And each micro instruction within it, we have a micro operations. It means a user program divided into mission instructions. Each mission instruction will have a micro program. Each microprogram is a set of micro instruction. Each micro instruction will have a micro operations. Now here I'm going to discuss how these micro instructions are going to be executed, and these micro instructions are going to be stored into the control memory. To execute these micro instructions, how it is going to determine the address of the next instruction, we are going to discuss in the address sequencing topic of the control memory. Now, when you look for the configuration of microprogrammed control unit, we have a control memory which stores the microprogram, which contains micro instructions to initiate the micro operations. And we have a control address register, which is going to hold the address in the control memory, which is going to read that control word and issues micro operations. And whatever the control word that is read from the control memory to be stored into the control data register. So what control address register will give you? Address in the control memory from where it has to read a control word. We call it as a micro instruction. That control word is read from the control memory and stored into a control data register. This control data register will have a micro instruction, which is again a collection of micro operations, so that it is going to issue that micro operations. After issuing that micro operations, it has to know which control instruction, which micro instruction which is available in the control memory to be executed. It should be decided. Means what should be the next micro instruction that will be decided by the next address generator circuit, we also called microprogram sequencer. This microprogram sequencer is going to decide what will be the next address of a control memory that has a micro instruction that is to be executed. That next address information is available in the control word that is there in the control data register. Based on that information, the next address generator circuit is going to determine the next micro instruction that is to be executed. Its address is going to be determined. That will be given as input to the control address register. This finding the next address is also the depending on the external inputs. So it finds the next address that will be given to the control address register. Again, based on the address value, It is going to read a control word from the control memory that is sent to the control data register. So it is having a control word. This control word will have micro operations that are issued, and this control word also have some information about the next address information that is sent to the address sequencer, and this process is going to be repeated so that it executes the micro program which is stored into the control memory. So what we have in this configuration of a microprogrammed control unit, we have a next address generator. What for next address generator? For determining the next address of the micro instruction within the control memory. And what control address register contains? The address of the next micro instruction to be executed. What is control memory? We are assuming control memory is a ROM. It is nothing but it is a static microprogramming. Microprogramming already available in the ROM circuit. It is reading and executing. It contains the microprogram. And what control data register contains or holds the micro instruction read from the control memory that is to be executed is there in the control data register. Now look at control memory is assumed to be a ROM, and the ROM control information is permanently stored, and the control address register, it is going to hold the next micro instruction that is to be read from the control memory. The control memory address register specifies the address of the micro instruction, and the control data register holds the micro instruction read from the memory. While the micro operations are being executed, the next address information is computed in the next address generator circuit. This is also called microprogram sequencer, and then transferred into the control address register to read the next micro instruction. Thus, we can say a micro instruction contains bits for initiating the micro operations and also bits that determines the address sequence for the control memory. Means which address is going to be uh, executed next, that is also going to be decided by the micro instruction. Means micro instruction will have micro operations along with some bits for deciding what could be the next address. The next address generator is also called microprogram sequencer. The next address generator is called microprogram sequencer as it determines the address sequence that is read from the control memory. Means which instruction that is to be executed next is going to be decided. The address of the next micro instruction can be specified in different ways depending on what sequence the microprogram follows. The typical functions of microprogram sequence are incrementing the control address register by 1. It is meaning that suppose it is executing the micro instruction 1, then automatically it has to execute next instruction 2, so that control address register initially has 1. After executing the instruction 1, it has to execute instruction 2, so that CAR is going to be incremented by 1. It is general purpose. General purpose in the sense it is general way where the program is to be executed sequentially one by one, so that every time CAR is going to be incremented by 1, or else loading the CAR with an address from the control memory. Suppose if it is executing instruction 1, next it has to jump to instruction 10. So next it has to jump to instruction 10 means CAR should not be incremented. CAR is to be loaded with address 10 so that it make a jump to the 10th instruction in the control memory, so that it is going to execute a microprogram that is starting from instruction 10. That is called loading the control address register with an address from control memory. Actually, this is required when in the case of conditional or unconditional branch. And third case is called transferring some external address, or fourth case, loading an initial address to start the control operations. Suppose after execution of one microprogram, it has to execute another microprogram. That another program is somewhere else in the control memory, let us say at 100th location. Suppose assuming the microprogram for add is executed, and next it has to execute microprogram for sub. Assuming microprogram for sub is there in the 100th location, so that it has to jump to that particular location. That is the initial address to start the control operation. These are the typical functions of microprogramming sequencer. Now, control data register holds the present micro instruction while the next address is computed and read from the memory. That's why the control data register sometimes is also called pipeline register, because it is going to have what next instruction to be executed. That information is available in the current instruction. That current instruction is held in the control data register. That's why we can call control data register is also called a pipeline register. Now, when you look for address sequencing in a microprogram control unit, what are the possibilities? An initial address is loaded into control address register when power is turned on the computer. So that which micro instruction initially it is to be executed when the power is turned on with a computer is going to be decided. And that initial address is loaded into the control address register. And mostly this address is the address of the first micro instruction that activates the fetch routine. Means very first it has to fetch an instruction from the main memory, so that whenever you switch on the power, so that it has to load the starting address of the microprogram for the fetch routine. So that fetch routine is going to fetch an instruction from the main memory. At the end of fetch routine, the instruction in the instruction register, means after fetching an instruction from memory, that will be there, that is stored into the IR register. Now that instruction is going to be decoded, so that the control memory next must go through the routine that determines the effective address of the operand. Once effective address computation is completed, the address of the operand is available in the memory, and next it has to execute the current instruction. The next step is to generate the micro operations that execute the instructions fetched from the memory. Means control unit should decode it and understand what kind of instruction it is. Suppose the kind of instruction is add, then it has to generate the micro operations for addition. So that the micro operations to be generated depending on the operation code part of the instruction. Let us say it is add or sub or div or mul. It has to decide. And each instruction opcode has its own microprogram. Like if it is add, add will have one microprogram. If it is sub, sub will have one microprogram. Mul will have one microprogram. And that microprograms are available in the control memory. Now it requires to transform this operation code to the address of microprogram which is available in the control memory, is called a mapping process. Look at the transformation from the instruction code into address in control memory, where that particular microprogram is located, is referred to as mapping process. It means to decide the next address information. What are the possibilities? The one possibility is incrementing the control address register by one, so that it executes immediate next instruction. Second, maybe unconditional jump or conditional jump, depending on the status bits. Like status bit means, like if it is positive, it has to make a jump. If it is negative, jump. If it is equal to 0, if E flip flop is set, like this. If the sign bit is 0 or 1, we can call positive or negative. Based on that status bit conditions, it has to make a branch to some different part of the memory, control memory, so that it has to jump to different micro instructions, and that micro instruction to be executed. And third possibility is a mapping process. What is a mapping process? Mapping the opcode bits of the instruction to the address in the control memory. And the fourth part is a facility for a subroutine call. It means one microprogram is calling another microprogram. Suppose this is a microprogram A that is calling microprogram B. Suppose the microprogram A is calling microprogram B, it has to execute the microprogram for B and come back. This is called a subroutine call. It means in the sequence, we have a four possibilities. One is immediate next micro instruction to be executed so that control address register is can be incremented. Another is maybe branching, maybe conditionally or unconditionally. Third is mapping the opcode bits to the address in the control memory where the microprogram for that particular opcode is available. And fourth one is subroutine call. Based on these four, we have to design a microprogram sequencer. Now, how it looks. We have a control memory. Control memory will have control words we call micro instruction, and that micro instruction will have micro operations. And control address register will host the address of the micro instruction that is to be fetched from the control memory next. And based on the address, it is to read a micro instruction from the control memory. And that micro instruction is going to issue micro operation. After that, the control address register can be incremented so that it can execute the immediate next micro instruction. This is one possibility. And or else it can be branch to different location. Branching to different location is based on maybe conditional branch or unconditional branch. That will be decided based on the branch logic. Branch logic will be decided based on the status bits. Assuming there are 8 status bits like positive, negative, uh, and E flip-flop is set or interrupt flip-flop is set. There are different status bits are there. Based on status bits, it has to decide whether branching is to be done or not. So assuming if there are 8 status bits, that 8 status bits can be selected. One of the 8 can be selected by using 3-bit information. Like if 000, we can say the result is positive. 001, the result is negative. If 010, the E flip-flop is set like this. We have 8 status bit conditions. Each status bit condition can be represented with a 3-bit number so that it has to decide what is the status condition based on the branch logic. This is called as selecting a status bit based on the branch logic. And this is one possibility. This is incrementing is one possibility, and selecting the branch address is the second possibility. And the third possibility is a subroutine call. Suppose if it is a subroutine call, first it is executing the instruction number 1. The next address is available in the control address register. Means next address is 2. Suppose if it make a jump to 10th instruction and execute up to 20, then it has to back to second instruction. This is a return address. That return address is available after incrementing the control address register. Currently it is 1. After incrementing it is 2. Then but one instruction make a jump to 10th instruction. 10th to 20 is completed. Then it has to back to second instruction. Now, second instruction means it is an incremented address. That incremented address will be stored into a special register called subroutine register. We also call SBR. So it may be returned to the calling program. That is a third possibility. And what is the fourth possibility? Mapping. That is mapping opcode bits to address in the control memory for that microprogram. That is instruction code is mapped with a mapping logic. Some logic is to be followed to map the operation code bits with address in the control memory. Suppose operation code bits is 010 and this is for addition. So this 010, assuming if it is addition, so addition will have a one microprogram in the control memory, at which location? So that this opcode bits will be used to map to address in the control memory. So that assuming opcode is 010 and it can be added with extra bits to represent the control memory address. Assuming left side there are 2 zeros and right side there are 2 zeros are added. So it means this location 0001000 will be used as a location for add microprogram. And this mapping is based on mapping logic. That mapping logic is the fourth possibilities. It means the next address can be one of these 4 possibilities. One is either incremented address. Another is maybe based on the branch logic. Or third one is maybe subroutine, or maybe fourth one is a map logic. Among the four, it has to select one of the possibilities. To select one of the possibilities among the four, it uses a multiplexer circuit. So the multiplexer circuit will select one among the four, and that one will be loaded into the control address register. Based on this address value, it is going to read a control word from the control memory. It is going to read a control word from the control memory, which is going to issue the micro operations for execution of that micro instruction. This is what called address sequencing circuit in the control memory. Here we use a status bits for conditional branching, and there are different status bits, and branch logic is implemented by testing the specified conditions, and unconditional branch occurs by fixing the status bit is always 1. And these are the things already we have discussed, and this is for your reading purpose. When it comes to the mapping of instructions, it is to map the operation code bits with address in the control memory. So operation code bits assuming 1011, here it is following a logic that the most significant bit is set to 0 and the least significant 2 bits are set to 2 zeros, and this is an operation code. It means how many bits are there? 0 1 0 1 1 0 0 means totally 7 bits we are using for operation code microprogramming address. It's 7 bits means we are using a control memory of 2 power 7. 2 power 7 is equals to 128 words. Means a control memory to address a control memory, we use a 7-bit address, and that 7-bit address is representing some part in the control memory. In that part, for this operation code, some microprogram is there. That starting address is given so that it is going to execute that particular microprogram. So transforming that instruction code bits to address in the control memory is called mapping procedure, to map the operation code to address in the control memory. And we use subroutines for calling the subroutine program and return back to the calling program. That will be done by using a special register called subroutine register, and this text is for you to read, and these things we have discussed in the address sequencing circuit. And that's about the address sequencing operation in the control memory. Hope you have understood. And if you like the video, do like, share, and subscribe. And don't forget to click the bell icon for the regular updates. Thank you.